Hey everyone, welcome, and thank you for taking some time out of your day to join the wolfSSL 2024 Roadmap webinar presented by wolfSSL Engineering Manager Chris Conlon. My name is Cameron. I will be moderating the webinar. All attendees will be in listen mode only. If you do have any questions, please use the Q&A box. We will host a Q&A session immediately following the presentation. The webinar will also be recorded and made available on our YouTube channel shortly after the presentation. I invite you all to follow us on Twitter at wolfSSL, as well as our other social media platforms. Also, feel free to email us if you have any additional questions. It would be facts@wolfSSL.com. And now I'd like to give a brief overview of the company before we move into the technical presentation. Today, Wolf SSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. Wolf SSL is made up of over 50 dedicated employees, most of which are engineers. This progress is, of course, supported by a strong partner network that we're extremely proud of. Since the beginning, our engineering team has developed several embedded security products, including Wolf Crypt with DO-178 support, FIPS certification, and FIPS ready offerings, MQTT up to the V5 specification, SSH v2, TPM 2.0, a secure bootloader known as Wolf Boot, as well as Java wrappers and JSSE support, and commercial support for curl. All these offerings are accompanied by thorough maintenance and support plans up to the 24/7 level. We also offer full service consulting. And now I'd like to turn it over to Chris to talk about Wolf SSL's 2024 roadmap.
Thanks, Cameron. And hi, everybody. Like Cameron said, this is Chris Conlon. Thanks for joining us today. We like to take this opportunity every year to present our 2024 technical roadmap. As far as what we've outlined so far, this can change throughout the year and also based on customer and user feedback. So, either in this presentation or afterwards, if there's things that you don't see on this roadmap that you're interested in, let us know, and that can sometimes help influence either this year's roadmap or potentially next year. I'll start out with elaborate a little bit on the overview that Cameron gave you as far as overview of our company. We secure data all over the internet. We have customers in all the industry verticals that you can see on this slide, in addition to some others. We're essentially securing anything either at the cryptography level or securing data in transit using a number of protocols. One of the big advantages to having the breadth of applications being used in is kind of a more expanded testing. So the more we can get tested in different environments, the better for everyone. We focus on three main areas: securing data at rest with cryptography and Wolf Crypt, data in transit with a number of protocols. So our primary one is SSL and TLS with Wolf SSL. We also have SSH with Wolf SSH. Typically, people are running us over TCP/IP sockets, but you can use pretty much any kind of transport layer that you have available. And then we mix those together into a secure firmware update solution. You'll see in a slide or two, we have Wolf Boot, our secure bootloader, mixed with a secure transport protocol to get the image down to the device. Like Cameron said, we're a growing company. We've grown every year since we were started. We have over 2,000 commercial customers now, 17 resale partners, and we estimate we secure somewhere over 2 billion active connections at any one time on the internet. This slide gives you a good overview of our current product lineup. The products on the first row there are what we consider our primary products. All these are written in C. We have wolfSSL and Wolf Crypt, which if you download those from our website, come bundled in the same wolfSSL package. But we do offer a build option that allows you to split that out into a Wolf Crypt only build if that's what you need. We've got a couple of validated versions of Wolf Crypt for DoD and government consumption, FIPS 140-2 and 140-3. Wolf Crypt DO-178 is a certification for avionics. And we do have an asynchronous crypto module for use on the server side with accelerator cards like Intel Quick Assist or Cavium Nitrox. We have our own MQTT client library called Wolf MQTT, an SSH client and server library and application collection called Wolf SSH. Wolf TPM is a lightweight TPM 2.0 library. Wolf Boot is our secure bootloader. And then Wolf Sentry is one of our newer products, an embedded intrusion detection and prevention system. Those products in the second row are language wrappers around wolfSSL. So we have customers that like to use us from Java in the form of JSC or JCE providers, C#, Python, JavaScript. We also have a few others. We have a Go wrapper that's not on this list. That third row is applications that we have available for SSL termination, certificate enrollment, secure update, command line utility we call wolfClue. And then we do offer support and consulting around curl with a resource constrained version of that called tinycurl. We like to do a lot of testing on wolfSSL. We think we're one of the best tested crypto libraries that you can find today. As such, we like to put effort into testing every year, expanding that, doing different kinds of testing, being more scalable, testing on different kinds of platforms. You can see some of the things we do now on this slide, everything from basic API unit testing through some more static analysis and fuzz testing. We do get peer reviewed by a number of different parties around the world, either academic or by some of our customers' test labs. We like to wrap a lot of this stuff up into a continuous integration cycle using Jenkins. We started using Google Compute Engine on the back end to help us be a little more scalable in launching VMs and testing there. So overall, the more testing we can do, the fewer vulnerabilities and bugs will make it into our stable releases. So here we get to our roadmap slides. We essentially have one slide per category here. One we like to look at every year is, how do we increase the performance of wolfSSL and wolfcrypt? You'll see here, we've got some assembly optimizations on the roadmap for ARM64, PowerPC 32-bit, and RISC-V. We have a couple different math libraries. One of those is called SP Math. And in that math library, we have a small build configuration called SP Small that's designed for users who are on low resource or low footprint devices, where you can minimize the footprint size of the math library. It does pretty good at being small, but it's not really that fast. So this year, we're going to see if we can optimize the performance of that up a little bit. We'll also be putting some effort into adding multi-threading and non-blocking support to our asynchronous crypto code. FIPS 140-3, we have a couple different certs in progress for this right now. For those of you who don't know, this is the kind of the successor to 140-2, where we had a couple certificates there as well. This slide is outlining the new features that you'll see in our upcoming 140-3 certificate. We're adding some functionality inside the boundary in the form of new key derivation functions for TLS, SSH, and SRTP. Adding a few more AES modes, including XTS and OFB, giving you some newer, larger RSA key sizes, 3072 and 4096-bit support. This will be a brand new certificate. So, FIPS certificates are valid for 5 years. So it'll give you the maximum 5-year certificate runway for use in your applications and projects. And one of the architectural differences between 140-2 and -3 is the algorithm self-tests that run when the module is loaded. 140-2, these are conditional. So they only need to run when a certain algorithm runs for the first time. So for example, if the first time you use ECC, the ECC algorithm tests will run. Same with AES, same with SHA-256, etc. So that can help increase the startup time of some devices. We also like to look every year, how can we reduce resource usage of wolfSSL? That might be stack or heap use, or that might be footprint size. This year, we'd like to put together some recipes for small build combinations. So, looking at what are some common subsets of features that our users are consuming, and how do we provide them kind of an easy out-of-the-box way to enable that subset of features? So that could either be through a new enable option with configure. That could also be through an example user settings file. We do like to take a pass over our TLS handshake every year. So we're going to do that again and see where we can reduce down peak memory use, either during the TLS handshake or after that when the connection is just in an idle state. And now we've got a lot of configure options in wolfSSL. We have, several hundred. So it's not really that clear anymore to new users what are the most beneficial configure options for me to use in my project. So as a documentation effort this year, we're going to document the top 10 most beneficial options as we see them applying to users in general. DO-178Z, this is a certification for avionics. We've certified to the DAL A level. This gives you a little glimpse at our roadmap here as where we're headed next. Right now we've done part of Wolf Crypt. And so we'll be looking at Wolf Boot, Wolf TPM, DTLS, and then adding more crypto level algorithms based on customer demand. Wolf MQTT is our MQTT client library. This year, we're going to be looking at the MQTT sensor network gateway and adding TLS 1.3 in there. That's a way for you to do MQTT in a very resource constrained sensor environment where the sensor would communicate to a gateway first and the gateway would communicate back to the end broker. It seems like a few times every year we get asked, do we have the broker side of the equation? This would let us live on both sides of the connection. It would make it easier to do optimization, to layer in new features, more progressive things like post-quantum support, for example. So we've got that on our list to try to get to this year. And we're also going to try to put together a Visual Studio extension. This will just be a usability improvement for those users on Visual Studio. For Wolf Sentry, this is our embedded intrusion detection and prevention system. This is designed to be a very lightweight way to monitor a connection or a set of connections, detect some kind of traffic pattern happening, and then take some kind of action based on that. So right now it's fairly minimal where users get to write logic to recognize traffic patterns, and then write logic to do something about that. That might be as simple as logging a notification to a file. That could be going further and shutting down the connection completely. So here we're going to add some more out-of-the-box attack mitigations, so users have to write less code themselves. One example of that would be, recognizing a DDoS attack on a CAN bus network. There's a number of popular logging notification frameworks, so we're going to try to add some integration into those notification systems out of the box as plugins. And then we'll bring Wolf Sentry support into more of our products. So you can build, for example, wolfSSL with Wolf Sentry underneath. That combination already exists, but we'll be, pulling Wolf Sentry into some of the other products as well. wolfSSH is our SSH client and server library. We do offer standalone production ready client and server applications with wolfSSH as well. For the client application side, we're going to be adding SFTP support to it. We do support SFTP and SCP in the library, but we haven't added that to the client side yet as far as the client application. We'd like to add bcrypt support. This would give users an option to use this for private key encryption in place of the OpenSSH style. And then adding additional algorithm support with ED 25519, some post-quantum support with Kyber, hybridized with X25519, and then Poly 1305 and Cha-Cha 20. DTLS 1.3 we've had implemented in wolfSSL for a few years now. I think we're one of the only libraries out there that implements this. We have a pretty full implementation. There's a few gaps that we're missing. One of those is connection IDs. So typically you'd associate a connection with a host IP and a port. But if those aren't available in some environments, you can use these connection IDs. So we'll be adding in support for that, as well as examples of how to use them. As long as we're working in DTLS 1.3, we're going to take a pass over performance to see if we can optimize that a little bit, and then add in some more testing as far as regression tests go. wolfglue is our command line utility. The idea here is that this would be an equivalent replacement to something like the OpenSSL command line application, where you could do things like generate keys, generate certificates, do encryption operations, message digest, things like that. We've got a good number of features in here right now, and we'll be adding PKCS12 support to wolfClue. We'll be adding some ASN1 parsing support. So if you wanted to dump out the ASN1 formatting of a X59 certificate or a PKCS7 bundle, that'll be doable. And then we'll be adding in PKCS7 and 8 support, ED 25519 and ED 448. Every year we like to do some ports into new open source projects. So this involves, taking OpenSSL out or the existing crypto library or TLS library and adding in wolfSSL support to those projects. We can either do the rip and replace, or we'll provide like a build option where when you build the project, it's an enable flag or equivalent. We've done a bunch of these so far. One we have on the list for this year is PHP. And a lot of times users will be interested in these types of ports if you're looking to, say, use FIPS-based cryptography underneath some of your open source ports or open source projects. We've got a lot of these now, so it's also about time for us to take an update pass over existing ports and see if we can bring them up to their current project versions. Hardware acceleration, this is in the context of wolfSSL and wolfcrypt. We support a lot of platforms right now where we can offload the cryptography operations into crypto that's implemented in the silicon or in a coprocessor or in a TPM module or an HSM. We'd like to add some more of these every year since we keep seeing new ones come up from users and customers. These are some platforms we have on the list right now to add support underneath wolfSSL for. The STM32H5, the STM32MP1, Microchip's DSPIC33, the Nuvoton NewMaker, the Microchip SAMI 54, and the Infineon Oryx Tricore, which is going to be added via a newer product we're coming out with called wolfHSM. wolfHSM will allow you to run that product on top of a HSM, but for the operations that are not available in the HSM hardware, that can be done inside of wolfcrypt software. wolfboot is our secure bootloader. Every year we add a handful at least of new platforms to wolfboot. wolfboot is designed to have a dual partition architecture where you have your main firmware running in one partition and you have an update that you put into a second partition. That second partition can be flexible on where it lives. It can use external memory if that's needed. And then when your application kicks off an update, we do a sector by sector swap. We've got some nice features in there, anti-rollback protection. If the power goes out mid-update, we can resume where we left off when the device comes back online. So this year we're going to be adding some more platform support. We'll be adding ARM Cortex-A. We've been playing around with putting wolfboot inside the secure area of Trust Zone M for ARM64. Adding in new architecture support for MIPS. We've got the Infineon Oryx Tricore and the STM32H5 and H7 penciled in on the list here as well for new platform support. Wolf TPM, this is our TPM 2.0 library. This would sit on top of pretty much any TPM 2.0 module out there today and allow you to access that, store keys, use keys, and potentially certificates from the module. And this can also sit underneath some of our other products like wolfSSL. This year we'll be adding endorsement certificate support and the ability to read that out of the module. The ability for Wolf TPM to actually do the firmware upgrade of the TPM firmware itself. And some of the newer Infineon chips have X509 support. So, storing and using the X59 certificates from the TPM module. A few years ago, we added a ABI safe API layer inside of wolfSSL. So we've got a couple customers that want to do binary updates of wolfSSL from release to release, where they don't have to or they don't want to recompile their application code. They just want to drop in a new compiled wolfSSL library. And that is safe to do as long as you're inside of the 112 APIs that are currently available in this layer. We are going to be adding a couple more of those APIs this year. Language wrappers are typically around wolfSSL or wolfcrypt so that people can use us from other programming languages. We've got a number of them that you saw on the early product slide lineup. We'll be adding a wolfcrypt level C# wrapper. Right now we only have a SSL and TLS one. For our Python wrapper around wolfSSL, we'll be adding pre-share key support. We'll be adding additional Java JCE class support, and then trying to do more interop testing at the JSSE level with some of the other JSSE providers like Sun and Bouncy Castle. A couple new language wrappers on the list for this year are Rust and TypeScript. For post-quantum support, we've been working in this for quite a few years now, actually. You may know NIST has been going through their post-quantum algorithm competition. And as they went through that process, we started by adding support for liboqs and PQM4 to wolfSSL. They implement all of the kind of post-quantum algorithm contenders. And that allowed our customers to achieve a post-quantum TLS handshake. Now, as NIST is starting to roll out draft RFCs for some of these algorithms, we're actually doing our own implementations of those algorithms inside of wolfcrypt. As we do that, we're going to optimize them for footprint and for performance as well as we can. So we do have Kyber done internally, and Kyber MLChem being the new name for that. That was actually released in our last wolfSSL version, which is available now to existing customers under no additional charge. You can also find some benchmarks we have on our website. We've benchmarked that in a couple different products in a couple different ways. We're also going to work on adding LMS support and XMSS. As we add the LMS, we'll be adding a PKCS11 interface on top of that, and then trying to bring some of this post-quantum support into wolfclue, so you can more easily do some of those post-quantum operations from the command line. You might need to generate some keys or certificates, for example. This slide is here as a reminder that we do have Daniel Stenberg on board as a wolfSSL engineer, and so we provide commercial support and consulting for curl. We have TinyCurl, which is a resource-constrained version. The goal of TinyCurl is to have a footprint size of 100 kilobytes, including wolfSSL, giving you kind of an HTTPS client that you can put on a microcontroller. And some other plans that didn't fit in the above categories. We'll be looking at the Chinese SM9 cipher, looking at if it makes sense for us to write our own FPGA crypto implementation that would kind of be a complementary or alternative option to wolfcrypt software cryptography. And then looking at CBOR support, this is a condensed binary representation that uses JSON, which we may be able to use for firmware updates. So that brings us to the end of our list. Like I said, we'd be interested in hearing any feedback you have, any features or new support you're looking for that wasn't on the list. So I'll go ahead and open it up for questions if anyone has any.
Awesome. Thank you, Chris. First here, can wolfSSL add support for new unsupported hardware cryptography modules? If so, how long does that typically take?
Yeah, good question. So that we can definitely add support for new hardware crypto modules. It depends on the scope of the algorithms that are inside of the module, but typically that takes us, on the order of a week or two. Something we can pretty easily add as part of our consulting services, as long as we can get a hold of the hardware or the development board.
Cool. Next here, can wolfSSL be built to use only static memory with no dynamic memory use?
It can, yeah. So in a lot of safety critical environments, you are not able to use dynamic memory. So we do have a static memory only build, which essentially eliminates all dynamic memory allocations and just switches it to using a static memory pool. So you should be able to find documentation on that in our manual. And I think we've got a separate web page dedicated to it as well. If you just search for just static memory.
Cool. Awesome. And where can I find a list of open source project ports that wolfSSL supports?
Yeah, for a list of open source ports, we have a GitHub repository that's under the wolfSSL organization called OSP, Open Source Projects. And there you'll find all the patches that we've done to things like Nginx, HA proxy, OpenSSH, WPA supplicant, etc. Some of those we do try to upstream most of those, and some you'll find upstream in the project proper. So the WPA supplicant, host AP is upstream. Things like Lidi is upstreamed. But I would look at the OSP repo first and then potentially go from there.
Awesome. Cool. That concludes our questions here. Thank you, Chris, for hosting an informative webinar, and thank you for everybody for joining the webinar. I'll be emailing out a copy of the webinar and would be happy to provide any PDF slides if needed. Please don't forget to follow us on Twitter at wolfSSL, as well as our LinkedIn and YouTube channel. If you have any questions that come up later, shoot us over an email to facts@wolfSSL.com. Thank you again, and we'll see you next week for an introduction of stateful hash-based signature schemes with Anthony Hugh. Take care, everybody.